Suppose we start with the exponential equation x to the a equals x to the b. Take the log of both sides. This will give us a times log x equals b times log x. Log x is equal to log x, so these can cancel, and that's going to imply that a is equal to b. This is really useful, because what it implies is if we can write an exponential equation like this, since x is the same, it implies that a is equal to b. So here's the rule. If x to the a is equal to x to the b, a is equal to b. So if we have an equation x to the a equals x to the b, that tells us that we can also say a is equal to b. We're going to look at a couple of examples. The question says, write each expression with base 2. First one they give us is 4 to the 6. Take a pair of brackets. 6 is our outside exponent. I'm going to write 4 as 2 to the exponent 2. Inside exponent times outside exponent tells us that this is going to be 2 to the exponent 12. Eight to the exponent 3. Could use the same technique. 2 to the exponent 3 will give me 8. 2 times 2 times 2. My outside exponent is 3, so I'm going to do inside times outside. This is going to give me 2 to the exponent 9. One over 8 to the exponent 2. They want the base to be 2. 2 to the 3 would give me 8. 2 to the negative 3 will put the 8 in the denominator. 2 to the negative 3 is the same as 1 over 8. Negative 3 times 2. 2 to the exponent negative 6. How do we write that with base 2? The base is 2. I need to know the exponent. Well, the definition of log is if I take the log of a number, it gives me the exponent that I need to raise the base of the log to get that number. So if I had log base 2 of 14, think about it. Log base 2 of 14 is going to give me the exponent that I need the base 2 to be raised to get 14. Also remember 2 times log 2, so if these two bases are the same, essentially you get 14, which is that. This is going to be key in the later few sections. Question number 2. Question number 2 says, write each expression with base 3. So I have 27 squared, and I can write 27 as 3 to the exponent 3. 3 times 3 times 3. Got inside exponent times outside exponent. Remember, the exponent of 3 there is 1, ninja 1. So if I bring the 3 to the top, it'll become 3 to the exponent negative 1. And then I've got my inside exponent times outside exponent, which will give me 3 to the exponent negative 4. I can write 10 as 3 to the exponent log 3 of 10. One over 2 is equal to 3 to the log base 3 of 1 over 2. Question number 4 says, write each expression as a single power of 4. So I've got 3 as my outside exponent. 16 is the same as 4 squared. And if that makes you uncomfortable, you can also see that the square root of 16 is 4. And then you have an outside exponent of 3. Well, what is 4? 4 is 4 to the exponent 1, ninja 1. That's going to be 4 to the exponent 3. Remember, the cube root means the exponent is 1 over 3. 16 is the same as 4 squared. It's going to be inside exponent 2 times 1 over 3. Remember, 2 times 1 over 3, there's an ninja 1. 2 times 1 is 2, 1 times 3 is 3. So this here is 2 to the exponent 6. That's what 64 is. The square root is 1 over 2. We've got a 3. We've got 128. So this 3, that fourth root is the 1 over 4, and I'm going to write 128. 128 is 2 to the exponent 7. This is going to give us 2 to the exponent 6 times 1 is 6. 6 divided by 2 is 3. This one, I've got 7 over 1 times 1 over 4. That's going to give me 7 over 4. And then I'm multiplying it by 3, which is really 3 over 1. 3 times 7 is 21. 4 times 1, 4. Now, I'm multiplying something with the same base. So I'm going to add the exponents. So I've got 3 over 1 plus 21 over 4. If I multiply this by 4 over 4, this becomes 12 over 4 plus 21 over 4. (33 over 4). Now, here's a little tip. I want this exponent to be 2, because that would give me 4. But if I'm going to multiply by 2, I need to divide out that same 2. So let's see that in slow motion. This number, where did the half come from? I want to cancel out that 2. But instead of cancelling it out, 2 squared is 4. 33 times 1 is 33. 4 times 2, 8. And I can use that same technique for D. D says radical 2 So I'm going to use the same strategy. I'm just going to work it out in terms of 2 and then transform the 2 to a 4. This is going to give me, this is 2 to the 1/2 times 8. This is 2 to the 1/3 times 4. 1 over 2 times 8 is 4. One over 3 times 4 is 4 over 3. When I add those two, I've got 2 to the 4 over 1 plus 4 over 3. This 4 over 1 is really 12 over 3. So when you add those, you're going to get 2 to the exponent 12 over 3 plus 4 over 3. Now, here's that little tip. I have 2 to the exponent 16 over 3. I want this to be squared. But if I'm going to put that 2 in there, I'm going to divide it out outside. This is 4. 2 divides into 16 8 times. So your final answer is 4 exponent 8/3. Finally, we're going to work on solving exponential equations. The main idea is to write both sides with the same base. I've got 2 and I've got 4, and I can write 4 as a power of 2. So 2 to the 4x equals. So there's my exponent x plus 3. And instead of 4, I've got 2 squared. So this 2 squared came from there. Two to the 4x equals 2 times x, 2 times 3, same base. I can equate the exponents. So 4x equals 2x plus 6. Four x minus 2x equals 6. 2x equals 6. X equals 3. Alright, 25 to the x minus 1 equals 5 to the 3x. So I can write 25 as 5 squared. This will give me 5, 2 times x, 2 times negative 1, since my bases are equal, I can now say 2x minus 2 equals 3x. Minus 2 equals 3x minus 2x. Minus 2 equals x. Alright, I'm going to write 9 as a power of 3. So I've got 3 to the w plus 1 equals 3 squared. Now that my bases are equal, I can say w plus 1 equals 2w minus 2. So 1 plus 2 equals 2w minus w. 1 plus 2 is 3. 2w minus w is w. Alright, I can write 36 as a power of 2. Six squared is 36. This is going to give me 6. 2 times 3m is 6m. 2 times negative 1 is negative 2. And just like in the other examples, my bases are equal. So I can say 6m minus 2 equals 2m plus 5. Six m minus 2m equals 5 plus 2. 6m minus 2m is 4m. 5 plus 2 is 7. M is equal to 7 over 4.